Greetings, fellow cosmic voyagers. For centuries we've gazed at Mars, picturing a barren, dusty world. But what if beneath that rust-colored surface lies a hidden world of water? Today we're diving deep to uncover the top 10 discoveries of subterranean water on Mars. We're not just talking about a few frozen molecules. Think vast reservoirs, potential liquid lakes, and ancient aquifers that hint at a wetter, more vibrant Martian past. Thanks to robotic explorers like NASA's InSight lander, we now have evidence of vast underground water locked deep within the planet's layers. These findings are reshaping our understanding of Mars's climate and its potential to support life. So buckle up, we're about to embark on a journey that will forever change how you see the red planet. Number 10 on our list, a discovery that shook our understanding of Mars, literally. NASA's InSight lander wasn't designed to look for water directly, but to listen to the planet's heartbeat using a sensitive seismometer. By analyzing Marsquakes, scientists mapped the planet's interior much like doctors use ultrasounds. InSight's data revealed a layer, 300 to 400 kilometers down, that was less dense than surrounding rock. The best explanation? A massive, sponge-like layer saturated with water. This isn't just ice. At those depths, pressures and temperatures could allow for liquid water locked away from the harsh surface. Mars's water didn't all escape or freeze at the poles. Much of it may be stored deep within its crust and mantle. This deep reservoir could contain more water than all the Great Lakes combined. It's a game changer for understanding planetary evolution and the potential for life. For future explorers, it's a tantalizing, if currently unreachable resource. But for the search for life, it opens a new, deep frontier. Could life have retreated to these depths and survived? The mystery deepens. Number 9 takes us to Mars' frigid South Pole, where ESA's Mars Express made a science fiction-worthy discovery. Using the Marsis radar, scientists detected a bright, reflective area beneath a mile of ice, evidence of a liquid water lake about 20 kilometers across. How can water stay liquid in such cold? Chemistry. The lake is likely a brine, rich in salts like perchlorates, which lower water's freezing point. Further analysis suggests this may not be a lone lake, but part of a network of briny lakes and slushy sediments. These subglacial lakes are similar to those beneath Antarctica, which harbor unique ecosystems. The discovery ignites the imagination. Could these dark, salty environments be habitats for microbial life? Mars' hidden lakes may be the best places to search for life today. The red planet's story is far from frozen. The search continues beneath the ice. For our 8th discovery, we look to the past, at the fingerprints of ancient aquifers within the Martian crust. High-resolution images reveal vast networks of canyons and chaos terrain shaped by catastrophic outflows of water. These features suggest immense volumes of pressurized groundwater were suddenly released, carving channels in a geological instant. The source? Deep, confined aquifers breached by volcanic or tectonic activity. Mineral analysis supports this. Clays and sulfate salts formed by long-term water-rock interaction are found in layers. This evidence paints Mars as a hydrologically active planet, with a stable, long-lived groundwater system. Ancient aquifers may have provided protected, subsurface environments, potential cradles for life. At number 7 we see Mars in motion, the mysterious recurring slope linii, or RSL, dark streaks that appear and fade with the seasons. These narrow lines emerge on sun-facing slopes when temperatures rise, then vanish as it cools. The leading theory? Briny water seeping to the surface from shallow underground, darkening the soil before evaporating or refreezing. Spectroscopy reveals hydrated salts, perchlorates, acting as antifreeze, allowing water to flow even in the cold. While some debate remains, the evidence for briny water is strong. If true, liquid water is present near the surface of Mars today, just centimeters down. This has huge implications for the search for life and for future human missions. Mars's slopes may be weeping with the remnants of a hidden water cycle. The red planet is more dynamic than we ever imagined. The search for accessible water continues. Our 6th discovery overturns old assumptions. Water ice isn't just at the poles. Data from Mars Odyssey's neutron spectrometer revealed high concentrations of hydrogen. Evidence of water ice, just a meter or two below the surface in mid-latitudes, closer to the equator than expected. Vast sheets of ice hidden under dust and soil are widespread across the planet. In regions like Deuteronomus Mensae, debris-covered glaciers preserve massive ice deposits. The surface debris insulates the ice, preventing it from sublimating away. This makes water ice much more accessible for future astronauts, no need to drill miles down. Mars's mid-latitude ice brings a self-sustaining human presence one step closer. The red planet's resources are more abundant than we thought. Our fifth discovery comes from SHARAD, a high-resolution radar aboard Mars Reconnaissance Orbiter. SHARAD mapped layers of ice and rock beneath the surface, confirming vast, thick sheets of water ice outside the polar caps. In Utopia Planitia, it revealed an enormous ice deposit, larger than New Mexico, with as much water as Lake Superior. This ice, mixed with dust and rock, was likely deposited during a colder, wetter epoch. The dust acts as a protective blanket, preserving the ice for millions of years. SHARAD's data lets us map the purest, most accessible ice, vital for future exploration. These ice sheets are time capsules holding a frozen record of Mars' climate history. Drilling into them could reveal the story of Mars's water cycle. Our fourth discovery is hands-on. NASA's Phoenix lander touched down in Mars' far north in 2008, aiming to dig up water ice. Using a robotic arm, Phoenix scraped away the topsoil and revealed bright white material, water ice, confirmed as it sublimated in the thin Martian air. For the first time, we had visual proof of water ice just inches below the surface. Phoenix went further, scooping up icy soil and analyzing it in an onboard oven. The result? Water vapor detected. Phoenix had tasted Martian water. This was a monumental moment, moving water on Mars from theory to fact. Phoenix proved that vast regions of the Martian high latitudes contain accessible water ice. This resource is there for the taking for future explorers. The mission bridged the gap between orbital data and ground truth. Mars's water is not just a distant dream, it's within reach. The red planet's secrets are being uncovered, one scoop at a time. The search for life and resources is now grounded in reality. Mars is ready for the next step. For our third discovery, we look for ancient hydrothermal systems, places where volcanic heat met groundwater. On Earth, such environments teem with life, fueled by heat and minerals. Orbiters have detected minerals like silica and carbonates in Martian valleys and craters, hallmarks of hydrothermal activity. In volcanic regions like Nili Patera, deposits of opaline silica point to ancient hot springs. These systems could have provided long-lived, energy-rich oases for life, even as Mars grew colder and drier. Hydrothermal vents are prime targets in the search for biosignatures, chemical traces of past life. Mars's ancient warmth may have nurtured life in its depths. The search for these lost oases continues. Our penultimate discovery isn't a reservoir, but a chemical key perchlorate salts in Martian soil. First found by Phoenix and later by Curiosity, perchlorates are widespread and profoundly affect water's behavior. These salts absorb water vapor and lower the freezing point dramatically. Brines can stay liquid down to -78 degrees Celsius. This means liquid water can exist in far more places on Mars than previously thought. Perchlorates explain features like recurring slope lineae and allow for thin films of liquid water just beneath the surface. The habitable zone on Mars is defined not just by temperature, but by chemistry. While ultra-salty water is challenging for life, some Earth microbes thrive in similar conditions. The discovery of perchlorates opened new possibilities for Martian habitability. Mars's subtle, salt-driven water cycle may be the key to finding life. Chemistry, not just climate, shapes the red planet's story. Our number one discovery is the grand synthesis. Mars history is not that of a dry rock, but a world with a deep, complex hydrological system. All the evidence, deep reservoirs, subglacial lakes, ancient aquifers, seasonal brines, widespread ice, hydrothermal vents, and salt chemistry, paints a stunning picture. Mars once had a thicker atmosphere, a magnetic field, and stable surface water, oceans, lakes, and rivers. As the planet changed, water retreated underground, freezing into permafrost, or seeping into deep aquifers. This migration extended Mars's habitable lifetime by billions of years. The story of water on Mars is the story of habitability. Each discovery is another chapter in a world that had all the ingredients for life. The question is no longer, was Mars habitable? The evidence says yes. Now, we must ask, was Mars ever inhabited? From seismic whispers to salty tears, Mars's story is being rewritten. These discoveries reveal a planet transformed, with water locked away in a deep, cold vault. Mars is looking more and more like a place we might one day call home. The quest to understand Mars is a quest to understand ourselves. Each new discovery brings us closer to answering, are we alone? The journey is just beginning. Keep looking up. As we continue to unravel the secrets of Mars together, your curiosity fuels our journey. If you've enjoyed exploring the red planet's hidden wonders, don't forget to hit that subscribe button, just like that little rover exploring new frontiers. Give this video a thumbs up to show your support, and drop a comment below with your biggest Mars question or theory. Your engagement helps our community grow and keeps the spirit of discovery alive. Together, let's reach for the stars, one discovery at a time. Thank you for watching. If you enjoyed this journey, please subscribe, like, and comment below to support more cosmic explorations.